We're going to get on. Look at lesson 8. There's a review for the exam if you go to lesson 8.
Okay.
Just an FYI, like a practice test kind of thing. I was just clicking around and I found that. Okay, well, maybe we can go over it when she gets done. Should we get started?
Yeah.
Let's start the quiz meeting and hopefully, I don't know what else to tell her. Okay, let me go to start quiz. Let's see. Okay, why don't you guys start reading them and then we can get done before your battery dies.
Okay, so number 3 says use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left equals z negative 1.358. Round your answer to the nearest to the 3 decimal places and then example.
Okay. I'm going to just try to text her the link.
Yes.
Right.
Find the combined area. So 1.358. Negative 1.358.
Okay, she's got it. So she should be getting on. And I'm going to pull up our little applet. Or not.
Under the standard normal curve that is to the right.
Yeah, so it should be in the middle, right? We're looking at the middle section.
I think.
Because you have an equal number on the left and an equal number on the right. We just want to know what the middle is. So
0.8255. Right?
I got 0.175.
Sorry.
Oh, we round it, so it'd be.
So you get 0.826?
Yeah.
Okay. Oh, and he said to make sure that we carry it out all the way each time until the answer, because that's where a lot of students mess up too. They start rounding before they just write a bunch of numbers when you're calculating. Okay, number 4. Which of the following will have a smaller?
What did you get for 3?
So first
0.826.
I got 0.175.
Okay, so click out the sides.
No, I actually, because I was moving, I already took this quiz.
Oh,
and
okay.
I got that one right.
How did
you find it?
Okay, let me pull up my curve thing. Hold on, let me pull out my notes.
Okay, maybe we need to read it better. To the right and to the left. So maybe it's not the centerpiece.
Oh, okay, I got it. So it's not the center, it's the 2 sides. So it's 0.175. She's right.
You're right. Okay, that makes more sense.
1.7.
Okay,
Okay.
178.
175. 0.175.
Okay. I have to click over. I need to click out some of these screens here. All right. Okay. Thanks, Lauren, for saving us.
Yeah, seriously. We
Yeah.
both.
Yeah, I did it ahead of time because I'm moving, so I just wanted to get it done. But
Yeah.
Okay, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? Smaller standard deviation. The distribution of an individual's observation X, the distribution of the sample means, or the
I don't know this
human.
one. The distribution of the individual observations.
I don't think we have enough information to determine that, to be honest.
If 9 observations are randomly drawn. I think if I had to guess, I don't know for sure, I would pick the distribution of the sample means.
Just like we have no numbers to compare other than the number 9.
That's true. Yeah,
We have nothing else to compare it with. If we I can't say that it's smaller than the individual or it's bigger than the individual. I don't know what the individual is, so I'm going to go with the. What did you get, Lauren?
Cinnamon was right.
Yeah, this cannot be determined.
Yeah. No, the sample means.
Oh, the sample.
Oh, that's not what I was saying. I was like, oh, it's not enough. Okay. The distribution of the sample means. Okay, so we're on question 4. The distribution of the sample means, which is a small. Okay. I get it now because I remember now. This is that one where they did the graph and it would just put all that stuff in, and it was always smaller. The sample means distribution, standard deviation was always smaller than the original. I don't know. Why is
will have a smaller standard deviation if 9 observations are randomly drawn from a population. So if you have, I don't understand.
So how did you find it, Lauren? How did you find, or what was your logic behind choosing the middle one?
Well, I knew that it wasn't the last one because I don't know. I always feel like when they say that, they're most of the time wrong. But I actually had someone here helping me who was taking this class before. Excuse me. He was saying how this one was correct.
Okay, so let's go on to the next one.
Let's go to the next one and come back because there's. Yeah. Okay, I still feel like there's not enough information, but maybe I'm just not reading it right. Okay, which of the following results implies that the spread in the standard deviation or the sample mean, decreases as the sample size increases?
Is it the central limit theorem?
Are you asking me?
Yeah, I think it's the central limit theorem.
No.
It's not normal distribution. That wouldn't affect. It's not the empirical rule. It's the law of large numbers just says that the means of the population and the mean of the sample are the same if it's a large number group.
Is it the large number one then?
Yeah.
Okay.
Because the law of large numbers says that as the sample size grows, the mean gets closer.
Okay.
The mean.
Okay, so where does it mean, like, in which of the following results implies that the spread in the mean, sample mean, right, decreases as, okay, yeah, okay, now I get it. I get what it's saying. Okay.
Okay, use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean 150.8 and standard deviation 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? So for this one, we would do 150.8 minus 160 over.
No, I think it's the other way. I think you got 160 minus 158.
Okay. Okay, see, that's what I get confused with. So it's, oh yeah, it's her score minus the mean. You're right, you're right.
Yeah.
Okay, so over 8.8, correct?
Yes.
I got 1.045. I mean, like, if you round it up.
1.045?
Yeah.
Is right.
Okay. What is the probability that a randomly...
Wait, go back. What did you have?
1.045.
Okay, so somehow I screwed this up. All right, I'll try it again on my own. Okay, keep going. I think I just pushed in wrong numbers, right? So I'm doing 160, right, minus 150.8 equals 9.2 divided by 8.8 equals, okay, now I got it right. I must have just put something wrong. I have this really weird, huge number. Okay.
Okay, for this one, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So for this one, crap, I forgot. How do you do this one? I need help with this one.
Actually,
you find your Z-score, but then you've got to plot it in the
under deviation, right?
So we're going to find our Z-score. Quantitative, okay, so what is the probability? So we have our Z-score right here. It's 1.045, right?
Yes.
We want to plug that into the little applet.
Okay.
And then we find the number at the top of the hill.
Negative 0. What was it, 145?
Yeah.
Yeah, but it was a positive number, right?
So I have to get going because I have to start moving some boxes.
Thank you for helping us.
No problem. Cinnamon, I sent you an email on how to do the next one.
Okay. Thank you.
Thank you.
No problem.
Bye.
All right, bye.
Okay. So what did you get for your area?
0.442. Is that wrong?
I got 0.148.
That's what I got too.
Because you're only looking at anything greater than that Z-score.
Wait, okay. What did you get?
0.148.
148. Can you tell me how you did that? Because I don't.
Okay, so you put your Z-score in right at the bottom.
Uh-huh.
So 1.045. So now it's about the shading of it. So you're wanting to, we know that this is 160. And so we want what's greater. So we just want to shade anything bigger than it.
Let me see. Hold on. See, my thing, can you zoom in on your, what do you have on the left side for the Z-score?
I'm over here.
Uh-huh.
I have negative 1.045.
Oh, that was my problem. Okay, I did 0.145.
Oh, okay. Yeah, that makes a big difference.
Okay, what was the area again?
So the area is 0.1480.
148. Okay, perfect. Thank you.
Okay, so go back over here. Put that in 0.148. Okay, so question number 8. A random sample of 5 students was selected to take the GRE. Their scores were all this. What is the Z-score corresponding to the sample mean of these student scores?
So we have to find the mean of those numbers, correct?
Right. That's what I'm thinking.
Okay, let's see. Okay, I got 160.
Okay, that's what I got.
Okay, so we have the mean. And then,
We have to find the C score of it.
yeah, so then the mean is 160. So would it be just 160 minus 160 over the standard deviation, which is, what was the standard?
Corresponding, oh wait, okay, so this is the sample, random sample of students taking the GRE. So are we going back up and our sample that we're pulling from, is that the 150.8?
Oh, yeah, you're right. So wouldn't it be the same answer as our first one because Diane earned a score?
Yeah. That's what I'm thinking.
Yeah.
I think they're saying if you don't get the mean right, you're going to get the answer wrong. So hopefully you know how to do the mean.
Yeah.
So would be that 1.045. Okay. Let's go to number 9. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answer 4 decimal places. Example.
Okay, so.
Isn't that the same one we just did? Like if we said it was 160.
But I think that since it says, oh yeah, you're right. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So they have to be higher than 160. So we go to the applet, negative 1.45, right? Is the
just 1.045.
0.45.
Which makes a probability of 0.148.
That's what I got, yeah. But we ran 4 times. 0.1480. Do you think that's what it is? I mean, it looks like it's too easy to.
I know. Unless you just don't understand what you're doing, then.
Yeah, like we're. What do you think, Min?
Min, what do you think on these last 2? Were they just too easy, or did we just totally get it wrong?
I think we should do something else with that.
Yeah, because it's too easy. It's like the same thing we've been doing, you know?
Okay, so I'm going to go back up here. It says use it for the next 4 questions. So 6, 7, 8, and 9. Okay, so then we go to 7. We go to 8. 8 says a random sample of 5 students was selected. Well, yeah, there's our 5 scores. So I'm going to add them up again. Maybe I added them wrong. But if you guys got 160 and I got 160. 160.
I think 160 is right.
I think the mean's right, yeah.
What's this?
And if we're using the same data from above, then I think I think it's the same thing.
Okay, wait. Since it's asking that 5 randomly selected students, do we add to the standard deviation, the square root?
We have to square root it.
Yeah.
That's what it is. You're right. Okay, so we already know that now we know what the standard deviation is. Now we have to, or the z-score. So we have to take the 8.8 divided by the square root of 5.
Mm-hmm.
That's what we did wrong. Every time I think I get this, then I guess I really don't.
There's like one step.
Yes. Okay, so do this 160.
So divided by the square root. What did you get for the standard deviation?
Okay, hold on, I haven't finished it all the way. I'm one step still. I'm like, that is too huge. Okay, hold on. Here, so
Let me see.
okay, so I got 2.338.
I got
That's what
2.8.
What did you get, Min?
That I got 2.338 too.
Okay. What did you get? Kimmy?
For the entire, hold on one sec. So it's 160 minus, hold on, let me do this. 160 minus 150.8 over, oops. What did you guys get?
Oh,
2.3.
I got, hold on, I'm back this up. I got 2.338.
I got 2.338.
Okay. I think we're on the right track then.
Okay.
Okay, what is the probability that 5 randomly selected students will have the mean score that is greater than? So now we need to go put that in the applet, right?
Yeah.
2.338. And that is like 0.0097 or 00 or 0.010.
I think it's 0.0097 with the right one.
Yeah. Zeros,
You don't think you round that up to the 10?
no, because it says around 4 decimal places.
Oh, okay. I didn't read that part.
So 0.0097.
Yep.
Oh, it is. I guess I better pay attention to all the directions.
No, it's so
Okay. Here's some information. Suppose that the GPA of these students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. Okay. What is the shape? If they're going to pull that much,
it would be approximately normal.
yes.
Yeah.
Okay, 11. What is the mean of the distribution of the sample means for all possible samples size 81 that could be drawn from the parent population? It's the same as what the parent population was, wasn't it?
Yeah.
3.5.
0.5.
Okay, and then what is the standard deviation of the distribution of the sample means for all possible samples? Okay, so this is where we're going to do 81 square rooted, which is 9. And we have the 8.8. Wait, no, hold on. What was the?
The standard deviation for this one is
0.7.
yes, 0.7 over 9.
Okay.
So we got 0.078 for your answer.
We round 3 decimals, so
0.078.
0.
So 78, 0.78.
0.078.
Okay, that's what I got.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So we have to use the applet, correct?
Oh.
Yes.
So
No,
negative
I just scrolled past all that.
0.078. It says more or less. I forgot. Less.
Less.
I got 0.469. Is that what you guys got?
Okay, what is the probability of GPA for A1 students randomly selected will be less than 3.3?
What did you get again?
I got 0.469.
0.
Okay, I have a, hold on, let me go back up. Maybe okay, there's our distribution. There's our standard deviation. Right, and so we're plugging it in. But how do we know less than 3.3? Do we have to go and figure that out? Like through the whole process?
Oh, because the GPA is 3.5.
Yeah.
Oh, you're right.
So we have to do that whole process again with this new information.
Yeah.
Oh my
So
god.
we have 3.3 minus whatever that number was that they told us.
And the mean was 3.5, I think.
3.5 is the mean over the 0.7 divided by the
Square root
of 81 or 9, which
81, which is 9, yeah. So then we get minus 3p. Dang it. Yeah, for the test, we have to be sure to like really read the problem because I would have just assumed it was the.
Yeah. It's confusing.
All
so I have 0 equals negative 0.2.
I got negative 2.571. Is that what you guys got?
Well, yeah, so I'm almost there. I just had to double check and kind of go back, and I forgot to put the negative in.
Using the applet for this problem, right?
So I got negative 2.56.
Negative 2.57. That's what I got.
Negative 2.5. Oh, I didn't put enough numbers in there. That's why. I rounded too early. I took my number from above, and obviously was a rounded number. Oops. Okay. Okay, we can move on.
This is just the same, but it's greater. So don't you like? Oh wait.
We're on 13, right?
Yeah.
So we're using the applet, right? So we found our negative 2.571. And do we plug that into the applet?
I think so.
Because my number is really, really low for the applet.
What did you got?
I got 0.0051.
Okay, so let's reread this. What is the probability that the students will be less than 3.3? Yeah, so that's pretty small, like less.
Yeah, I think a lot of people would have
0.0051, like 0.0051.
Yeah, that's.
So if you run it out, it'd be 0.005 for question 13.
I mean, I think we're right. I honestly
I think
think
we are. I think we're right because we need to know what is less than. What is the probability, and that's probability is kind of that. That's what I always put probability. The P on top of the mountain. I don't know.
for probability, we use the applet, and I don't think we plug in our -2. But it's okay. -2, is that the z-score? That's what it is, right? Because
The z-score, yeah.
okay, then we're right. If we solve for the z-score and we plugged it into the applet and put less than, then we should be right.
I think we're right because the next one is going to change. What's the probability of it being greater?
Greater than 3.3. So
Yeah. So now we're just switching up the.
it'd be the same, right?
No, because now you're going to shade in everything but that because now you're going to go bigger than that, right? So you've just taken off your little tiny bit and you did all of this.
So it's 0.995.
5 or 5, yeah.
Yeah,
I don't know. That's what I think it is. I think that's what it's saying.
0.9.
Anything greater than 3.3.
And if you add up together, it equals to 1.
And it should all equal 1.
Yeah.
Okay, that makes sense then.
Yeah. It's a little weird, but I think we're right.
Okay. Let's do 15 and we'll see.
Okay. The U.S. Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of the random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample.
Okay, so we're doing the 177.6 minus the 185, right?
177.6 minus 185 all over
26.7 divided by the square root of
48.
48, right?
Okay, so he's just putting a bunch of words. That's all it is.
Yes, I agree.
So it's the same thing. Okay, for this one, the z-score is -1.920. Is that what you guys got?
Hold on, I'm almost there.
Yeah, that's what I got.
Okay. So the actual question is, find the probability that a random sample of passengers will have a weight that is extreme or more extreme.
So then we
And
just
what-
take the number on the top, which is 0.0549, which is going to be 0.055. Right?
Yep, I agree with you.
Okay, wait,
Okay.
I'm confused.
Like you just take the top, the number on the top,
Which number?
like the number next to A there. When you plug in your z-score,
Oh.
Put your
And then
z-score in. And we know that we're going to look at the big number because there's nothing negative. So we're looking on the big side.
Oh, wait, okay. You guys are a step ahead of me. That's why 1.920. Oh, crap. Okay, and then we're doing
the one on top.
And then we're going to look at the top number because we want to say, what's that shaded? What is the chance of us actually getting anything greater?
and you got 0.02274?
Yeah.
Okay. Man.
But now I just want to reread the question again to make sure that's okay.
Wait,
As
what
extreme.
answer did you guys got?
So we want to say as extreme, or we want to say the same as this number or more than this number. The
Oh.
extreme part always throws me off, but I think it's as this number or more than this number.
Okay, then you would do the center too. So it's 0.973.
No, because I still think it's on the line or more, that we are not only interested in values that are lower.
Min, what'd you get?
I got 0.0549.
That's not what I got. What did you get?
Positive direction. I think we got it right the first time.
Yeah, don't you like just put in the C score and I don't know, like my number
Oh
just
shoot, I didn't put my negative number in, that's why.
I put the negative. I put negative 1.920, right? For the Z.
Oh, I forgot my negative when I typed it in, and so I was looking on the, okay, so you're looking, it's still like the 0274, right?
That's what I got if we're doing that way. Wait.
So I'm just trying to figure out what he's really asking for. Okay, find the probability that a sample of passengers will have a weight that is extreme or more than was observed. Okay, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean. Okay, so now we're highlighting the two ends. Is that what we're doing?
0.0549.
Yes, I get it. Ah, sorry.
Yeah, Min's right.
I had to just like read it.
When
you
you
have to round it up.
I got it too.
0.055.
Yeah. Okay, I'm ready to submit this thing. This one was fine.
No, and to think it's only going to get funner.
I know, seriously. Okay, I'm gonna submit it right now.
Okay.
We got 100! Yay!
Woohoo! We did it.
Okay, that one was a tough one, but
That one was. Okay. I don't feel like I want to take this
all right.
test, though. I need some more practice problems so I can practice recognizing what it is it's asking me. That's what I feel like. I need longer homework sessions or something, more problems to work with so I can.
All right.
Yeah,
We sent the test. It's next week, right?
I think it's due Saturday.
Huh?
Here, I think.
Is it Saturday?
No way.
it's
I think it's next
Saturday.
week.
Hold on. Well, we'll just.
Oh my God.
Hold on. We'll just look over here and just see, and go down to the week 4, and go down to.
Oh, Unit 1 exam. Quiz opens in 3 days.
Okay.
Yeah, it's okay. It's homework.
Wait.
The homework ends on May 19th. The group collaboration.
May 19th is Saturday.
Yeah.
I'm getting that.
Unit 1 exam starts May 21st. So it starts on Monday and it closes on Wednesday.
Okay. I'm doing it Wednesday then.
I know. I'm like, okay, I can do it Wednesday. But we still have to do group 9 or whatever. Oh, I guess it's group 8. Oh, good. We get to do the homework. Okay. I was thinking it was this week and I was stressing because I had like pathophysiology on top of this. But good. Okay. I'll just focus on pathophysiology and not this.
Okay, so we'll see each other on Tuesday, right?
Tuesday, 8 o'clock or 9?
8 works for me. It's up to you guys.
I'm good.
We'll
Hey,
text.
Okay. Sounds good. Let's plan 8 otherwise. Okay. Thanks for helping me. I appreciate it. Bye.